So reputable scientists know the average surface temperature of the world has been rising steadily. The average rate of change is about 0.2 degrees Celsius per year. Aha, Celsius per year. That looks like a slope. And also it says average rate of change, which is another phrase that means slope. And the average global surface temperature in 1950 was 14.1 degrees Celsius. So that's our starting point right there. So thinking about y equals mx plus b, I have a slope m, and I have a y-intercept b here. Now they want me to use capital T for temperature and lowercase t for years. So we have to be case sensitive here. So the global surface temperature, that's what I'm calculating. That's my y value. So capital T equals 0.02. Instead of an x, they want me to use a little t for years since 1950, after 1950, right? So in, say, 1960, that's 10 years later, t would be 10, for example. So a little t there plus 14.1. So that's my equation to model this situation. Capital T, 0.02 little t plus 14.1 in 1950. And because we got slopes, rates of change, this is definitely linear. Which statement is the best interpretation of the slope? Okay, we talked about interpreting slope before. Before I pick one of theirs, I'm going to write my own. How do we write our own interpretation of slope? Well, to interpret slope, we have to remember that slope is rise over run. Now our rise, that's our change in the y values, and our run is the change in the x values. Well, what are our y values mean? In this case, our y values are temperatures. So my rise is a change in the temp. What temp? The average surface temperature of the world. My run, those are my x's. X's are years here, so that'd be a change in year. So change in year. So I have to take these two ideas that the numerator is a change in the average surface temperature of the world, and the denominator is a change in the year, and use that to relate the number 0.02. And if the number doesn't come as a fraction, we can easily write it as a fraction by just putting it over 1. Okay, so numerator, change in temperature. Temperature is the average surface temperature of the world in Celsius. Okay, so that's 0.02 degrees Celsius. And the denominator is just years, 1 year. Okay, so what this tells me is every year, since these are positive, the temperature is increasing by 0.02 degrees Celsius. So lots of ways to write that. The average, average surface temperature of the world is increasing, it's positive, by, I'm going to say about 0.02 degrees Celsius each year or per year. So that's my version of it. Then I want to go over to my sentences and figure out which one is the best change. Okay, so my slope has nothing to do with the 14.1. You're out of there. Let's see, the average global surface temperature is rising. Okay, I had increasing by about 0.02 degrees Celsius each year. Oh yeah, that's what I got here. This one looks promising. Let's look at the next one. The average global surface temperature is rising about 1 degree Celsius. No. It's rising 1 year, 0.02. This one's backwards. That one's out. All right, your order may be a little bit different. On mine, it is that second one there. And again, for me to write a reasonable sentence and compare it to another one, I pretty much have to write my own. And I have to write out all of this stuff here to be able to figure out how the sentence should be worded. And once I get that down, I can write myself a sentence. Next part, which statement is the Y-intercept? Okay, so the Y-intercept relates to the points 0b, right? That's the Y-intercept. So 0, that's years after 1950. And B, that's just the temperature. Okay, so in 1950, the temperature was 14.1 degrees Celsius. Right? So we were just given in that last part of the second sentence up there. So not that one. Oh, it's got to talk about 1950. The year 0, that's crazy. The year 0, right? That was like 2,000 years ago. So that one's nuts. This one doesn't reference a year. This one does. The average global surface temperature was 14.1 degrees in 1950. Yep, that was the average. We were given that right here. So that one is mine. Use the equation to predict the average global surface temperature in 2020. Okay, last year. All right, well, we have a formula. Our formula says that our average global surface temperature is equal to 0.02 T plus 14.1, and T is the year since 1950. So 2020 is how many years later? Well, if you're not sure, take 2020, and subtract 1950. So 50 plus 20, it should be 70. Whip out your calculator to double check. And again, your year may be different than mine. So I get 70 years later, so I would put a 70 in there. So 0.02 times 70, right? I'm gaining 0.02 degrees Celsius every year, 70 years. Add that to 14.1. What do I get? Calculator, please. .02 times 70 plus 14.1 gives me an average surface temperature of about 15.5 degrees Celsius. Next one. According to this model, in what year will the average global surface temperature reach about 16.8 degrees Celsius? Oh, so here they're giving me the temp and I have to solve for the year, round to the nearest year. All right, in what year? So that's going to give me 16.8 equals 0.02 T plus 14.1. We got to solve for little t here. We need a new piece of paper. I'm going to change the order. I'm going to write the 0.02 T plus 14 first equals 16.8. Make sure I got those right. Looks good. All right, solving linear equations, the first thing we do is get rid of the thing furthest away, which is the plus 14.1. So we will subtract it. Number take away itself is a 0, it's gone. So now I just have 0.02 T equals, let's see, 8/10 minus 1/10, 7/10. 6 minus 4 is 2, 1 minus 1 is gone. So I get, that's a change of 2.7 degrees Celsius. How many times did we gain 0.02? So next we divide. So we're going to break this multiplication by dividing by 200ths. Divide by 200ths on this side. Whip out the calculator, make sure I get the subtraction right, and make sure I get the division right. Okay, so first thing I had to do was take my 16.8 and subtract my 14.1. And that's the 2.7. Now I need to take that 2.7, my previous answer, and divide by my slope, 0.02. I get 135 years has to go by from when? from 1950. All right, let's write that down. So just cleaning this up a little bit, here I have a number divided by itself, which is 1. 1 times t is t. 2.7 divided by 0.02 was 135. And again, that t is years after 1950. So if I add these two together, that will give me the actual year. Let's see, what would that be? 5 and 3 is 8. 9 and 1 is 10. Carry the 1, should be in 2085. We'll get to about 16.8 degrees if the temperature keeps increasing at the same rate of about 0.02 of a degree per year. So calculator, let's double check all of that. We think it's 135. So 1950 plus 135 gives me 2085. Now to double check the 135, I should plug back into my original equation like I did for the 70 years later. So 0.02 times 135 plus 14.1 should be my 16.8. So again, what did I just do there? I'm checking to see if the 135 is actually correct. So is this right here? Question mark. I plugged it back in for t here to check. So whenever I can, I like to check. What happens if I take 0.02 times 135 and add that 14.1? My calculator said it is 16.8. So I was just checking to see if I solved this correctly. Yep, 135 years after 1950, which is the year 2085, the average surface temperature should be about 16.8 if the temperature keeps rising at 0.02 of a degree Celsius per year. Oof, that was a mouthful. And we've done it.